Hello viewers, welcome to the ETABS learning tutorial. Today is the tutorial number 5, and in this tutorial I will discuss this type of frame. You can see it is a multi-story, multi-bay, irregular frame, and we have different types of loading is here: point load, distributed load, and two types of distributed load: triangular and rectangular. If I show you the point load and distributed load and triangular load, and the distributed load are also varying, and at the bottom we see the fixed support is here. So I need to draw the shear force diagram, bending moment diagram, and support reactions of this frame. And this type of frame is typically analysis in different types of problems. So let's open the ETABS. So I'm opening the ETABS and then go to File, New Model, and click on No, and then you need to input the grid line. In case of frame, you have to always input number of lines in y direction is 1, which I have already mentioned in some of my previous lecture. So I input here 1, and in case of x direction lines, I need to open the elevation. And here is our frame, but I need to see through the plan, and I can see 1, 2, 3, 4 and 5 columns. That means I have to input 5 lines in the ETABS model. And just please see my previous lectures how you can calculate or measure the lines. So I input here the 5, and then you need to change the unit because I need to input the distance. Unit is keep feet. Then go to custom grid spacing, click on custom grid spacing, and then click on edit grid. Okay, in case of edit grid, there is option in right side, display grid as. There are two options, ordinates and spacing. So simply select spacing, and in the bubble size select or type as 3. I would like to have a 3 feet bubble size, and you can see the spacing is changed. So I need to input the dimension. So our first dimension is 10 feet, 12 feet, 15 feet and 13 feet. So I am going to input there. First is 10, and then is 12, and third one 15, and last one is 13. So I can just overcheck 10, 12, 15, 13, and we also have 10, 12, 15 and 13. Then click on OK. So our grid line is given here. Now I can see I would like to input the story, and you can see 1, 2, 3, 4 and 5 stories here. So the story height are not also same, they are different. So I would like to input that in ETABS. So open the ETABS. So number of story is 5, and since our story height is not uniform, go to custom story data, and then click on edit story data. And in that window you need to input the story height or different story. We have 5 story. So first story height is our 7 feet, then 10 feet. So I input here 7, then 10, and next is 12, 10, 8. So next is 12 is given, 10 and 8. So 8, 10, 12, 10, 7, 8, 10, 12, 10, 7. Please be careful while you are inputting the story height. Check the unit must be as keep feet. Okay, then click on OK, and then grid only, select grid only and click on OK. So here is our grid lines of our model. I would like to select my left side as plan view, select on plan story 5, and in the right window I would like to select on elevation view, and there are 3 options here. So select on the elevation view, click on OK, click on 1, and then click on OK. So in the left side we have the plan view, and the right side we have the elevation view. So now I would like to create the beam and column. In case of frame structure, this type of framing structure, I would like to input the loads as live load, and I do not need to input different types of frame. But if you have different types of frame, then you must need to create different types of frame. For this member or for this particular frame analysis, I would like to use 10 inch by 10 inch frame size. So to define the frame size, go to define and then click on the frame section, and then delete by default frame section. There are huge by default frame section is given there. Just simply left click from the mouse and hold it and hold down, and by this way you can select all of the frame section and then click on the delete. I'm just selecting all of the frame section, then click on the delete property, and then click to option and select add eye/wide range. Click here, and you will see at the bottom side add rectangular. I would like to assign a rectangular frame. So after going to add eye/wide flange, go to add rectangular, and then give the section name. I would like to give the section name as frame. Change the material as concrete. You can keep it as steel. Then the size is 10 feet 10 inch by 10 inch, and no need to change any other option, because in case of frame we will apply the load as live, so you no need to think about the dimensions. But if your dimensions are different, like at the top story the dimension is one type, at the bottom story dimension is another type, then you have to change them. You click on OK, and another by default properties is here. Select and delete. So we have only one properties, frame we have already created. Then click on OK. So now I need to create the columns and beams and I would like to use my plan window. So just left click on the plan window, and at the bottom side there is option is here one story. Click on it and you will see all story. Then click on all story. Okay, then go to the draw line object, create columns in regions or add click. Select on it, then move the property window, and you can see our properties here, frame. And now left click on the mouse from the mouse and hold on it and move your cursor to select the whole line, that means whole plan, and release the key. If you release the key, then you can see all of the columns are created, and you can see the columns from top to bottom are created. Next, click on the select object to neutralize the cursor, and next I need to create the beam. So click on this icon from the left side, just click on it, and same procedure creating beam for the as like column. Just left click on the button of the mouse and then hold on and select all of the plan, and then release the key, and all of the beams will be created. See, all of the beams has been created. So our beam and column is created here. Now I would like to show, you can see that some by default support is also created here, and in the bottom base there are beam also created here. I will delete them later. And to edit or delete anything, I need to change the all story to one story. So click on all story and select one story. Okay, let's open the model, and you can see that our plan is here, and in the top we have only one span. So I would like to select rest of the columns and beam, and simply click delete from the keyboard, and all of the columns and beam selected has been deleted. And next again, and in that case we have only two bay, so I select on the rest of the bay or span and then click on delete. Okay, and rest is okay. So now I'd like to delete the beam at the base, because in our model we do not have any beam at the base. See, we do not have any beam at the base, right? So I need to delete them. Click and press delete from keyboard. Okay, deleted. Now I need to assign or change the support. By default some hinge support is come here. but we have fixed support. So click on the point here. I need to input the support. Just click on the point and then go to assign joint point restraint or support. Select the fixed support and then click on OK. So the support is also assigned. Okay, here is our model. I would like to show you the model as like our PDF file. So go to set building view options and then untick mark the story level and grid lines and global access and then click on OK. So here is our frame. You can see there are 1 bay, then 2 bay, and then 4 bay, and there is multi-story. So this is the model of a multi-story, multi-bay irregular frame. Just comparing our original picture, you can see the height and figure is given here. So our next task is to assign the load at different points. So I just click on the point where I need to assign the loads. So just click, then go to assign force and select on live, and you must okay, sorry, we don't have the access here. Just I'd like to open the access. Go to global access and then click on OK. Okay, so here is our x direction and y direction is given here. In the first load, it's go from left to right. That means our x direction. Just select on the point, go to assign joint point and force, then click on the live and unit is key fit, and in the x direction our load magnitude is 12. So I input here 12 and then click on OK. And you must see that the load case must be live and unit should be keep. So here is a load 12 key fit, so 12 keep, and you must change the unit as key fit from the right bottom end. And I need to input the next point load. So I click on the point and go to assign force, and I need to open the force. Our next force is 20 kips, so just simply input the 20 and then click on OK. So you have to input the rest of the 3 point. I am just using some shortcut, just to do as like same procedure. 30 kips. Okay, next 40 kips. Okay, and the last one is 10 kip. So our point load are assigned properly, and our next target is to assign the distributed load. So you can see we have two types of distributed load. One is triangular shape and one is regular. So first I will input this triangular load, and this load is here in that span. So select that span and then go to assign frame or line loads and then go to distributed, click on it, and the load frame distributed load window will appear, and select their load case name as live, unit as key fit, and since it is a trapezoid, since a triangular load, which is why I need to input as trapezoidal load, and select on the absolute distance. And you can see we have to consider only this span, and the load will the distance will come from the left end, this point. So our first at this point distance is 0, load is 0, and the peak will come at the middle of that span, which is our 12 feet. I can show you, it's 12 feet. So the peak will appear at the 6 feet distance at the midpoint. So at 6 feet the load magnitude is 3, and at the right end our distance is 12 and load magnitude is 0. Since our span is 12, so the distance is 12 and load magnitude is 0. Then click on OK. So you can see our triangular load is assigned properly. And next I need to input this distributed load. They are uniformly distributed load, no triangular shape or no trapezoidal shape. And you can see the load are not same, they are varying, so I have to select on the span by span. So first I select this span where the load magnitude is 1 kip per feet, select and then go to distributed. And you need to delete the previous load, just simply put 0, otherwise the triangular load will also add with this span. So since the first span or uniformly distributed load magnitude is 1, I just simply click here 1, type 1 and then click on OK. So our 1 kip per feet uniformly distributed load is assigned here. And next I will input a load here because this is 3 kip feet. Just simply click on it, assign, then go to frame or distributed load and just change the magnitude of the uniform load as 3 and then click on OK. And the load is also here. So next we have 2 span and both span has 2 kip per feet, so I select the both span at the same time, click on it and same procedure, just go to assign. Okay, and select the uniform load as 2 and then click on okay. But please remind that the load direction must be always be gravity. I forget that for the distributed load the load comes from top to bottom, so the direction will be gravity. And there are also other direction too, and in my previous lectures I discussed some angular loads and angular member where you have to change the direction. In our case I will select the gravity and the uniform load is 2 and then click on OK. So all of our load is assigned here. Here is, you can see the distributed load. So go to the display and then go to the join point, select the live and click on OK. So there is our point loads, and again go to display and select on the live and click on OK. So all of our loads are assigned properly. So our next task is to analysis. So go to analyze and simply click on run analysis, and then a small window will appear to, and it asked you to save your model. So I would like to save it at anywhere. I could rename it as multi-bay multi-story. So multi-bay and multi-story, and then click on save, and then the analysis will start. So viewers, if you did not subscribe my channel, please I would like to request you to subscribe my channel, and please hit on like and share if you like this video and think this video is useful to you. I need your subscription very much. So next my target is to find out the shear force diagram, bending moment diagram, reactions and the deflected shape of this frame. Already the deflected shape for dead load is here. We do not need that. I need to show the shear force diagram and bending moment diagram. In the left window I would like to show you the shear force, so I select the elevation view in the left window. So I go to display and then go to show member force and then go to frame or spindle forces, and in case then change the load case as live. If you would like to show the shear force, then you have to select the in plane shear. If you would like to show the member bending moment diagram, then you have to select the in plane moment. Since in this window I would like to show the shear force diagram, so I will select the in plane shear here. So click on the shear force, and then in case in the option untick the fill diagram and tick the show values on the diagram, then click on OK. So all the values are appeared here, and it's little bit hazy. And in the right window I would like to show the bending moment diagram. So go to the display and then go to member force live and in plane moment as like shear force, since it show values on diagram, since the unit as kip feet, kip feet. So here is our shear force diagram, and at the right side we have bending moment diagram. go to set building view option and tick mark on the global axis, grid level and history level, and apply to all window, because I would like to hide the grid lines from the all of the window. So in the left window, Shear Force, and we have the bending moment diagram. So these values are overlapping each other. So if you'd like to find the specific value of any member or beam, just you need to simply right click on it. See, for example, I would like to find the bending shear force of this member. Just right click on it. Just simply right click on this member and you can see the value. And if I move the cursor, the value also be changed. Okay, so the value at the left end is 5.77 and the right end is also 5.77. if you'd like to show for this member, just simply right click on it, and if you move your cursor, the magnitude will also be changed and the unit will be keep fit. Since at the right bottom the unit is keep fit. If you'd like to see the bending shear force for this member or for this beam, so if you move your cursor, then the value will be changed. So here is how you can see the shear force of a beam. And now we will see the shear force of column. So right click on that column and the value is showing from the left end. So if I move the cursor, and then the value also be moving, so as like the beam, right? So for the same procedure I will apply for the bending moment diagram. If you would like to see the bending moment of a specific beam or column, just simply right click on the beam or column, then you will see the value. So for example, I just right click on that beam and the bending moment, the moment value is here. If I move the cursor, the value also changed. So in case of column, just simply right click on it. You can see there is a red marker is here, right? When I move the cursor, the red marker will ups and down. Look, the red marker is ups and down, and it denotes where is the magnitude. So this is how you can find out the peak value and the lowest value, positive value, negative value, and the zero distance value. Everything you can find out from here. So our next target is to the deflected shape and reaction. Go to support member and support reaction, select on the live and then click on OK. And in that window you can see our reactions are given here, the x direction, y direction, x direction and z direction, since we have not any load in the y direction. So now I would like to see the deflected shape of my frame in the right side. So I just click on the right side and go to the deflected shape, and the load is live, and click on OK, and you can see the deflected shape is here. So this is for today. I hope that you will try this video and lecture in your home, and if you face any problem then please let me know, and please subscribe my channel